Alright guys, welcome to Smart Spark Academy. So we are going to solve this question, differentiation. We are starting with this particular question since this will definitely be on a series. So we have y equals to x raised to the power of 3, and we have a sign in between these two values. We have our independent variable and also have our dependent variable. So why do we call x, or why do we call y dependable, or why are we going to call y independent variable and x dependable variable? Now, for you to have the value of y, we need to know the value of x. So it means that y depends on x. So y is our what dependable variable, while x is our independable variable. So let's solve this. In differentiation, this is just a simple formula. Assume we have something like, I'll say p equals to okay, the power of n. So what we do is this: for me to differentiate this, I can use, let me use p. We are going to use the power to multiply the base. That is say n times x, and then we subtract 1 from the power. Hope you get what I'm trying to say. So this is just all it means by differentiating. Use the power to multiply the base, then you subtract 1 from the power. So we simply have nx x minus 1. So we are going to come here to do the same thing. I'm going to use this method to solve this question. Then we use our first principle, because this method is more like back checking what you did in your first principle. So I have the y over the x equals to 3 times x, then 3 minus 1. So I can likely say 3x raised to the power of 2. So this is just all about differentiation. You multiply the base by the power and then subtract 1 from the power. So we are going to go into our first principle, and then we are going to solve it. I'll leave the answer here for you. For this particular question, our answer is 3x raised to the power of 2. So I'm going to clean this solution that I just gave you guys, and then I will use first principle. Using first principle method, we know for our f of x equals to um, x plus zeta of x, since there will be an increase in both right and left hand side, and then subtracting from the value of what x was all over delta x, limiting your delta x to 0. Or I can decide to bring this thing here since it's part of our question. So let me just bring it here, limiting delta x to 0. So my question was x raised to the power of 3. Let me say y equals to x raised to the power of 3. So I'm going to put this here. This will be my x. Whenever I see x, this value, I'm going to put everything that is here into this particular formula. So I'll take the step that is being used in this formula to solve this using first principle. So let me just write using first principle. Using first principle. So let's go ahead. So we increase both sides by delta x, delta y. That is first, just like what is being done here. So there will be an increase in both sides, delta y, and then our delta is are going to increase this. But since we look at our right hand side, there's a power which is raised to the power of 3, and we can't ignore that. So we are going to work on this. We are going to solve this particular expression that is at our right hand side. Now remember this formula. If I have a plus b or raised to the power of 3, where our x is a, our b is delta x. So I'm going to solve this. When I've gotten the answer, I'm going to impute those values, these two values in it, to simplify it. You can as well decide to solve it normally by just using this particular format, but sometimes it confuses students. So we always want to simplify it so that we understand. So if I'm to solve this, we are saying that this bracket is into 3, since it's raised to the power of 3. So let me say a plus b raised to the power of 2, and then a plus b, which is the same thing. Since the base are the same, if I add 1 plus 2 to give me 3. You understand? So let me simplify our a plus b square. The square of this, a square plus 2 times ab, and then plus our b square. Then all multiply our a plus b. So we are going somewhere. Now we use this bracket to multiply this other one so that we can open both brackets. Let's get our final answer. So we have a times a square give us a cube. A times 2ab give us 2a square b, and then a times ab square give us ab square, plus we use b now to multiply through in the brackets. We have our a square b, and then we have our 2ab square plus b cube. So let's get our final answer by collecting our like terms. So work with like terms now. We have a cube. We also have 2a square b. And you can see a square b here. You can also see a square b here. So we have this plus this give us plus 3a square b. And then this also 3ab square plus b cube. So let's compare this with this. So wherever you see your A, you are going to put X. Wherever you see your B, you are going to put delta X. So we'll just compare this to solve it. Simply saying that our y plus delta y equals to, what is there? A cube. So we have S cube plus 3s square, because there's a square here, so it will be s square. Then b, wherever I see b, put your delta x, plus we have 3a, so it will be 3x b square, that is delta x square. And then let's have plus delta s cube. So assuming I solve this particular expression at the right hand side, I'm going to have this, and assuming I solve it this way. But why I decided to use this is to avoid confusion because of there are similarities between your x and your delta x. I hope you do understand. So let's continue. Our next approach, or I'll say our next the next step we have to take is to subtract this value, because now we have done this part of it. We have simplified this place. We are yet to subtract it from here. So we are going to move y to the right hand side. We are subtracting this value. So it will be delta y equals to x3 plus 3x squared delta x plus 3x delta x square plus delta x cube minus y. And what's the value of our y? Value of our y is x cube. So wherever you see y, you have to put x cube. So let me put my x cube there. 3x squared delta x plus 3x delta x squared plus delta x cube minus x cube. So at this point, we can see that these two can go. S cube minus s cube will cancel. So we have delta y equals to 3x squared delta x plus 3x delta s square plus delta s cube. Now the next step says divide both sides by our delta x. You have to divide this place by our delta x. If I'm dividing this place by our delta x all over delta x. So this will cancel, remainder one delta x here, and then it will also cancel remainder delta x all over here. This delta x cancel this one, remainder one, also cancel this one. Let me just make it more proper. I'll clean this aspect of it. Okay. So let's continue. So we have delta y all over delta x equals to 3x square plus 3x delta x plus delta x square. So our formula says limiting delta x to 0. When you limit delta x to 0, this delta y over delta x will definitely change to the y over the x. That is, this will change to the y over the x. So you say when delta x of delta is equals to this, and then delta x equals to 0. So we are going to limit anywhere we see delta x, we are going to make it 0. That's what it means. So we have um dy over dx 3x square plus 3x all zero plus 0 square. That will be 3x square since here will be 0 and here will also be 0. So our final answer using first principle gives us 3x square, and this was our initial answer. We will use our normal differentiation rule by multiplying your power with the base and subtracting 1 from it. Alright class, let's solve this particular differentiation problem. I'll be using first principle. So using first principle. So I'll be using first principle to solve this problem. And the question states y equals to y all over x. We're asked to find dy dx. So our first rule is to addition of dy and then addition of dx of both sides. So you can do it this way. Sorry, what will be x since it's x that is here. So we are dealing with our independable and our dependable variable. And I told you guys that this is our dependable variable, which is y, and x is our independable variable. So after you have done this, what to do next is to move y to right hand side, because we are asked to simplify our right hand side first. And you can see it's already simplified. We don't have any other thing to deduce or simplify in this particular expression that is found on the right hand side. So what we do is to move this y to the right hand side. Now that here it's already simplified. So we have the y equals to 1 over x plus the x minus y. So what's the value of y? Value of y is y equals to 1 over x. Wherever I see y, you put 1 over x. So we have 1 over x plus the x minus 1 over x. You can see here from all here we have what? We have fraction. How do you handle fraction? When you see fractions like this, you can multiply by cross multiplication the denominator of the right hand side, multiply the numerator of the left hand side. Sorry, there's no equality sign here, so let me just use term. The denominator of the second term multiply the numerator of the first time. The denominator of the first term multiply the numerator of the second term, and then you use the operational sign if it is plus or minus. That is when this rule works. Is addition also division. Sorry, is division or multiplication. You use the other rule because those two they work with similar rules. Y plus and minus work with similar rules. So this is like a fraction here. So I will say x minus x times 1 is x, and then x plus dx times 1. So we have x plus dx, and then you multiply both denominator, multiply two of them. So we have our x plus dx, x multiplying x plus dx. So this is what we have. We are still moving with this. Our left hand side remains the same. Hope you are following. So the next thing we have to do now, after we have moved your y to right hand side, you are going to divide through by your delta x, but we need to simplify this place first. We are not done simplifying. You can look, we can simplify our numerator in our right hand side equation. So we have the y delta y equals to x minus x, x multiplying negative 1 outside, you are multiplying this bracket. So minus 1 times x give us negative x, and then minus 1 times positive delta x will give us negative delta x, because minus times plus will give us minus all over x bracket x plus delta x. Hope you are following. So at this point now, we are going to work and we have negative delta x because x minus x cancel. So we have negative delta x all over x bracket x plus delta x. So this is delta y. Alright, let's continue. Our next step is to divide both sides by our delta x. Remember in our rule, we have done with this divide both sides by delta x before you limit delta x to 0. So if I'm to divide both sides by delta x, I'm going to have um delta y over delta x equals to 1 over delta x times negative delta x because I'm dividing both sides now, so I can say 1 over. So like say divided by 2 to 1 over 2 times that particular entity. So if I'm dividing both sides, I'm going to use 1 over and use delta x to we have x bracket x plus delta x. So this will give me this cancel this. I'm left to negative 1 over x plus delta x. Sorry, there's x over there. Alright. Hope you understand. What I just did, I divide both sides by delta x. So I'm to divide this by delta x. It will definitely come under. But I decided to make it like 1 over delta x so that you can see clearly when I'm multiplying. Sorry, when I'm crossing, when I'm cancelling these two values. Because definitely it will cancel. So what we have left is negative 1. Since this will cancel this, we have 1 left all over x bracket x plus delta x. So move on by saying limiting. From to limit to say let dy over dx equals to dy all over dx and then the x equals to 0. So we have dy over dx equals to negative 1 all over x bracket x plus 0. So we have negative 1 over x square. So this is our answer for this problem. This is the answer. Hope you get what I just did here. To limit this thing, this will definitely change to the over the x. And whenever I see the delta x change to 0 because we are limiting delta x to be 0. So our derive at the x will be equals to 1 all over x square. Solving this particular differentiation problem and then we'll be using our first principle. Before we use our first principle, we use our normal differentiation rule to back check this equation, but we are going to back check it first before we use our first principle so that while solving the problem we'll be sure that our answers is aligned to what we are sure of. So normally we do say that the power multiply the base when you are differentiating. So when I'm differentiating from my left, 2 multiplies my base. My base is 3x. So it will be 2 times 3x giving me 6x. 2 minus 1 is 1. So my answer should be 6x plus 1 multiplies this and then 1 minus 1 is 0. X raised to the power of 0 is 1. So once is a one variable like this, differentiating it will change to 1. Once in one variable if it is one variable, but if it is a number, it's not a variable, like it's not x, it's not a letter, it's a number. It's is our constant and constant is 0. You understand? So that is how it is. So assuming here was 1 or here was 7, here was 5, then here should have been 0. Our answer should have just been 6x. So let's continue. So using our first principle, I'm using first principle to solve this question. I'll say let f of x become our y. F of x becomes y 3x plus x. So let's add up both sides. So we have y plus dy delta y rather equals to 3 brackets. Anywhere you see x, we are going to add up. So we have x plus delta x square plus our x plus delta x. So this way it's being solved. We ensure that this addition of your delta x to this one will also be done to this other one. But you work based on the power. So for the first one from your left hand, from the first one it has the power of 2. The second one has the power of 1. So we will not ignore that. So we'll start our right hand simplification. We'll ensure that we simplify our right hand first. Ensure you simplify your right hand first. So we have 3 brackets x square plus 2x delta x plus delta x square. I'm going to explain what I just did here to you guys. Now, we have something like this, a plus b, all raised to the power of 2. And we have to simplify this. This is just the simple thing. This bracket is 2. And if the bracket is 2, one bracket will multiply the other bracket for it to open. But if you want to just go straight to the answer, you take the square of the first term. Take the square of the first term. After that, you multiply 2 by this and this. What do I mean? it will be plus, if it's plus that is here, 2 times a, which is 2a, times b, that is 2 times a times b, that is 2ab. That is how it is, no matter what kind of variable that is here. If it was x plus 2, it should have been 2 times x times 2, which should give you 4x. So that's how this kind is being solved. Then for your last term, because then it will give you 3 terms, for your last term, it will be b raised to the power of 2. That is b square. Do you understand? That is how we solve this particular problem. If you want to just see this way, for you to get the right answer, you don't need to be passing through long processes. That's how I solve this. This is our x square, 2 times x times the x theta x and the theta x square. We also have plus our x plus delta x. So let's continue our simplification. We are going to open this bracket. Everything will be open here. So we have 3 times x square plus 3 times this give us 6x delta x plus 3 delta x square plus x plus delta x. So 3 multiplies this bracket plus x plus delta x. So now let's check if we can work on any like terms. If they are like terms, we are going to work on them. So we have x delta x, we have delta x square, we have x, we have delta x. So there are no like terms. If here was x, then we would have worked on our like terms to bring them together first, but there are no like terms. So let's continue our right hand side. We'll not ignore our right hand side. At this point, we move your y to the right hand side, leaving your delta y. So we have this like this. 3x square plus 6x delta x plus 3 delta x square plus x plus delta x minus your y. Because positive here, when it moves to right hand side, becomes negative. So what's the value of our y? Value of our y is 3x square plus x. This is value of our y. So we are going to impute it here. If I see y, 3x square plus x, you are going to impute it here. So we have 3x square plus 6x delta x. Ensure that you do not miss any of these steps. Don't imagine it when you are solving it, since it's a theoretical question. You write down all these steps because it counts very well in your exams. So we have 3x square plus x. Observe what I did. Why did I put this bracket? So that this negative will affect the two values. Because when it's negative y, 3x squared plus x, if I'm to simplify in continuation, just watch what I'm going to do. Because we are still simplifying. 3x squared plus 6x delta x plus 3 delta x square plus x plus delta x minus to open this bracket. So this our positive 3x square becomes negative 3x square, and also negative positive gives us negative. So you can see that our value y was 3x square plus x, but after it has come to right hand side, since our y is negative, everything here turns negative. So you can see 3x square cancel 3x square, and then x cancel x. So we are left with we are left with delta y equals to 6x delta x plus 3 delta x square plus delta x. So these are the values that are left with 1, 2, 3, 4, 5, 6, 7. Okay, 4 was cancelled out. So divide both sides by delta x. This is our next approach. Divide both sides by delta x. So dividing both sides by delta x. Remember, our answer is 3x plus 1. So as we are moving, we will also be looking at this answer to ensure that we arrive here. So what we have is this cancel this, we are left with 1 delta x. This gives us 1. So we have delta y over delta x equals to 6x plus 3 delta x plus 1. So we are going to limit limiting delta x to 0, and this becomes is 1, yeah, and this becomes limiting the x to 0, okay, and this becomes our dy over dx. So we have dy over dx equals to 6x plus 3 or 0 plus 1. So we have 6x plus 1. So this is how this thing is being solved. It's pretty simple. Alright, so we want to solve this particular question. Some of you be asking, how are we going to find dy over dx? Now, this question is pretty simple. We are going to use what we call the function of function. You can call it the chain rule. The chain rule. Okay, I'm going to show you how you solve this. Now, you can see that this question has a particular operational sign on it, which is our square root. And since there is no value here, we assume that this is square root. Let's assume there was 3 here, it will be cube root, but there's no value here. So we have something like y equals to 3x minus 5 over 1 over 2. Because if I square root u, is also known as u raised to the power of 1 all over 2. If there was 3 here, it shall be 1 over 3. Or I didn't say if 3 was here, it shall be u raised to the power of 1 over 3. So for chain rule, function of function, what we do is that for the brackets, we let the bracket to a particular variable, to one particular variable. So I'll say let 3x minus 5 equals to u. Or you can say let u equals to 3x minus 5. So our y will be what? Since this is u raised by 1 over 2, right? This is how it is. So we will now differentiate it. The y over the u. I'm going to differentiate this thing. And remember, I said when we are differentiating, our power multiply the base 1 over 2 times u, then we subtract 1 from the power. So 1 over 2 minus 1. So simply have um 1 over 2u negative 1 over 2. This is like half minus 1 is negative 1 over 2. So let's make this in use good. But to make it good, I'll say since this is 1 over 2, I already have u all over 2. But in my u over 2, I have negative 1 over 2. So if I bring it down, it will be 1 over 2 root u. Sorry, u. I'm going to explain this because sometimes it's confusing. So let me explain for you people. Normally, our differentiation of something like this should have just give us this, like we know that this is our answer. But how do we get here? Now, I said the power multiplies the base, isn't it? So 1 over 2 multiplies u, which is this. And then half minus 1, half minus 1, that is multiply 1 minus 2 all over 2 give us negative 1 over 2. So that is half minus 1. So half minus 1 is what? Negative 1 over 2, right? Okay. So we have negative 1 over 2 here, and this 1 over 2u. So let our u come down. We have 2 all over u all over 2 raised to the power of negative 1 over 2. And this negative 1 over 2 is mounted on this u. So for we to remove this negative sign so that we can put our half, because it's like u raised power 1 over 2 is root 2, but at this point it has negative sign and you cannot add this your root sign on top u with this negativity. So we already know that 1 over u raised 1 over 2 is the same thing as u negative 1 over 2. Take note of that. The inverse of this, we remove the negative sign. The inverse, we take the inverse of this particular number that is here, just like taking 1 over, we're talking about the inverse, that is 1 over that particular entity. So it will remove the negative sign to let it look like this. So because of the negative sign here, we are going to take the inverse, which is give us this, and then we convert it to root u. That's why the answer is 1 over 2 root u. Hope you understand. So I'm going to just write it there for the sake of space. So we have 1 over 2 root u. Do you understand? So this is what we have here. Now we continue. He said chain rules is like this is the law for chain rule. The y over the x is equals to the y over the u times the u all over the x. This is the formula for chain rule, or you can call it function of function. This is what we do. So we have gotten out the y over the u. What about the u over the x? Let's get out the u over the x. Now we said u is equals to 3x minus 5, isn't it? So we are going to work on this also too, so I can get this value. I've already gotten this value. So u equals to 3x minus 5. The u over the x, that is, I'm deriving this and differentiating this particular equation. It give me 3 because the power of this particular variable here is 1, and then 1 minus 1 is 0, is equal to 0, and then here becomes 0 because 5 is a constant, and every constant is 0 after differentiating. After differentiation, every constant is 0. So the u over the x is 3, the y over the u is 1 all over 2 root u. So we are going to solve it. So you can say therefore the y over the x, using this our formula says the y over the u times the u over the x. So the y over the u, 1 over 2 root u times 3. We will not stop here. We are very close to the answer. This is the value. We need to impute it. Our u is 3x minus 5. So we need to put it there. So we have 3 over, that is 3 times 1 now, over 2 bracket 3x minus 5. So this is our answer. The y over the x equals to 3 all over 2 root 3x minus 5. I hope you understand. For chain rule, this is the formula for chain rule. The y over the u times the u all over the x. Now take note of something. It can be more than this depending on equation. Depending on equation. So it can be more than this. That is, it can be more of this. But you must have your answer. So if I cancel the u, cancel the u, you have what? The y over the x. Yes, that is the tricks in this thing. So that is how this is being formed. Thanks for watching. Please subscribe to this channel and stay tuned for more videos like this so that you can do well excellently in your exams. Alright guys, we'll be solving this particular question. We're asked to find the gradient of the tangent. We're asked to find the gradient of the tangent, meaning that this is our tangent, right? We have to find the gradient, and it should just be one particular value. Our answer here will not be an equation. We are not asked to find the equation. We have to find the gradient. So when you see things like this, it's just pretty simple. Differentiate it. Sorry, I'm passing through the line. Um, Passing through the line, these 2 points, passing through this point rather. So it's passing through these 2 points. When you see things like this, what you have to do is to differentiate it. After differentiating, you impute the value of your x. When you look it from this point of view, you see that our x is -2. So we are going to put our -2 and we get the value of the x. Now take note of that, and then if you are looking for your divide dx, we use our normal rules. You don't need to go and use your first principle. Use the normal rule. So what we have, divide by dx gives us 3 multiplying 6x, which is 18x. 3 minus 1 is 2. Minus 2 multiplying 5x gives us 10x. 2 minus 1 is 1. Plus 1 times x, 8x is 8x. 1 minus 1 is 0, so raise the power of 0 is 1, so there will be no value here. And then -0, these are constants, our constant changes to 0. So this is it. We impute this value, to have our answer. So where x is equals to -2, we have 18 bracket -2 square plus 10 2 plus 8. We have 18. -2 square gives us 4 minus 10 times 2 20 plus 8. These are gradient. You can also change it. You can try to change this to m. You can say divide the x can be equal to m because m signifies gradient. And then do your 18 times 4 minus 20 plus 8. So let's do 18 times 4. That calculator with me. Just calculate with me. 4 times 8 give us 32. So we have our 2 kite 3. 4 times 1 is 4 plus our 3 becomes 7. And then minus 20 plus 8. So our gradient equals to this gives you okay, is 12 minus 12, and then we have 0 60. So 60 becomes the gradient. We can call it the slope. Now another thing you should understand, gradient, slope, divide the x, they are the same thing. Do you understand? So find the slope, same thing. Find the gradient, the same thing. So after you have differentiated, you impute this value. Since they said passing through the point, this the point is passing through. So let's assume I want to draw this particular graph now. Since the graph is like this, these are 0 bar. This is how the graph is, and then these are 0. And 0 is here. Our line on the graph is passing through -2x. Negative, this x, this y. This negative x, this y. This negative y, this positive x. But our line is passing through a -2. This one, this 2, this 3. And a +3. This one, this 2, this 3. You know what they mean? Let's say these are 2 now. These are 2, these are 3. We'll call this 4. Our line is passing through here. So the gradient, that is the slope, is what? 60. So you can write -2 and 3. When you calculate for the slope, after it has passed through this, you know the way you calculate for slope? By saying y2 minus y1, x2 minus x1. You calculate for slope like this, or you use your normal the one that has mx plus c. So you can say your m is equals to y minus c all over x. When you have solved for this, if I impute my 60 here, we'll be able to have my intercept, because I've already known that m is my 60, m is my slope. We'll be able to have my intercept. This is your linear, and then this for double. This one thing is 1 like this one. And if it was 2, so that is, I'm just trying to digress little so that you understand more about this. But this what it entails. Thanks for watching, and please stay tuned for our next video. Love you guys.